Mathematics makes our life orderly and prevents chaos. Certain qualities that are nurtured by mathematics are power of reasoning, creativity, abstract or spatial thinking, critical thinking, problem solving ability, and even effective communication skills. Math helps us think analytically and have better reasoning abilities. Reasoning is our ability to think logically about a situation. Analytical and reasoning skills are essential because they help us solve problems and look for solutions. What is calculus? From Latin calculus, a small stone used for counting. A branch of mathematics including limits, derivatives, integrals, and infinite sums. Used in science, economics, and engineering. Builds on algebra, geometry, and trig with two major branches differential calculus and integral calculus. Ancient history. In the early years, integral calculus was being used as an idea, but was not yet formalized into a system. Calculating volumes and areas can be traced to the Egyptian Moscow papyrus. Ancient Greeks. Greek mathematician Euclides used the method of exhaustion, a precursor to limits, to calculate area and volume. Archimedes continued Euclides' the idea and invented heuristics similar to integration to calculate area. Bonaventure Cavalieri argued that volumes be computed by the sums of the volumes of cross sections. This was similar to Archimedes. However, Cavalieri's works was not well respected, so his infinitesimal qualities were not accepted at first. Medieval history. In about 1000 AD, Islamic mathematician Ibn al-Hayy derived a formula for the sum of the four powers of an arithmetic progression, later used to perform integration. In the 12th century, Indian mathematician Bhaskarat II developed an early derivative. He described an early form of what will later be Rolle's theorem. Also in the 12th century, Persian mathematician Saraf al-Tusi discovered the derivative of a cubic polynomial. Modern history. Formal study combined Cavalier's infinitesimal quantities with finite differences in Europe. This was done by John Wallis, Isaac Barrow, and James Gregory. Barrow and Gregory would later prove the second fundamental theory of calculus in 1675. The history of calculus, Newton's versus Leibniz. The calculus controversy was an argument between 17th century mathematician Isaac Newton and Gottfried Leibniz over who had first invented calculus. Newton claimed to have begun working on a form of the calculus which he called the method of fluxions and points in 1666, but did not publish it except as a minor annotation in the back of one of his publications decades later. Gottfried Leibniz began working on his variant of the calculus in 1674, and in 1684 published his first paper employing it. Aristotle published a text on Leibniz's calculus in 1696. Meanwhile, Newton did not explain his calculus in print until 1693 in part and 1704 in full. While visiting London in 1676, Leibniz was shown at least one unpublished manuscript by Newton, raising the question as to whether or not Leibniz's work was actually based upon Newton's idea. It is a question that has been the cause of a major intellectual controversy over who first discovered calculus, one that began simmering in 1699 and broke out in full force in 1711. Dynamical systems, a derivative dy over dx represents motion or relative changes in variables x and y, but measured at a certain point, not before and not after, but exactly at that point. A curve in the plane represents the trajectory of a moving body, and as it moves along the curve, the derivatives tell in which direction the body moves next as the body moves along the curve. It sweeps through little increments of area, and if these are summed to define an area function, then when the curve is defined by some function y is equal to f of x, we can calculate the area function because the derivative of the area function is given by f. Static geometry. Given a curve y is equal to f of x, which is a static set of points x and y in the plane, the derivative dy over dx gives the slope of the line tangent to the curve at a point. The derivatives of p, f define the shape of the curve, and if we already know what the shape of the curve is, we can work backwards and figure out static geometry. Given a curve y is equal to f of x, which is a static set of points x and y in the plane, the derivative dy over dx gives the slope of that line tangent to the curve at a point. The derivatives of f define the shape of the curve, and if we already know what the shape of the curve is, we can work backwards and figure out what f must be. Taking this working backwards one step more, the area under a curve defined by f is given by finding an antiderivative of f. These two ways of describing calculus are equivalent, and both led to the fundamental theorem of calculus. Isaac Newton is credited with many of the beginnings of calculus. He introduced product rule, chain rule, and higher derivatives to solve physics problems. He used calculus to explain many physics problems in his book Principia Mathematica. Gottfried Wilhelm Leibniz, German, systemized the ideas of calculus of infinitesimal. Unlike Newton, Leibniz provided a clear set of rules to manipulate infinitesimal. Leibniz spent time determining appropriate symbols and paid more attention to formality. His work leads to formulas for product and chain rule as well as rules for derivatives and integrals. Newton versus Leibniz. There was much controversy over who, and thus which country, should be credited with calculus since both worked at the same time. Newton derived his results first, but Leibniz published first. Newton claimed Leibniz stole ideas from unpublished notes written to the Royal Society. This divided English-speaking math and continental math for many years. Today, it is known that Newton began his work with derivatives and Leibniz began with integrals. Both arrived at the same conclusion indefinitely. The name of the study was given by Leibniz. Newton called it the science of fluxions. Since then, there have been many contributions to build upon Newton and Leibniz. Calculus was put on a more rigorous footing by mathematicians such as Cauchy, Riemann, and Weierstrass. Calculus has also been generalized for the Euclidean and complex space. In conclusion, we will stand on the shoulders of those that came before us and study their findings and apply them to our module and to our modern world. Calculus deals with study of the rate of change and motion of objects. It deals with the calculations of the limits of the sums of quantities. The term calculus, which means a small tone or pebble used for counting in Latin, is usually referred to as analysis or the archaic term infinitesimal calculus. Calculus has two major branches, differential calculus and integral calculus. Differential calculus deals with the change of one quantity with respect to the change of another quantity. Some of its applications are in calculating the velocity and acceleration of objects, and estimating the growth and decay of materials or animals in the natural sciences. Integral calculus, on the other hand, deals with the amalgamation of small quantities to arrive at the desired result. It is a tool for calculating lengths, areas, volumes, work, and center of gravity. Is applied in the fields of the science, economics, and statistics. Sir Isaac Newton (1642 to 1727) and Gottfried Wilhelm Leibniz (1646 to 1716) are credited with the invention of calculus, but the ancient Greeks had been known to have calculated areas of polygons with the method of exhaustion. 2,500 years ago, the idea of the Greeks' method of exhaustion is similar to concepts found in calculus, although its method is geometrical. Euclides of Cnidus, 400 BC, used this method to provide the formula of the area of a circle E is equal to phi r square.